their period of time with Oliver and then just go from there.
Thanks, Bill. Just a few rules. Anybody falls asleep, we're going to stop. So, stick with us and we'll get through this. Bill, I've got a handout here. We're going to try and give you some insights into what was happening, about 52 years ago. And it's pretty hard for us old fellows to remember what we did 3 minutes ago, much less that long a time. So this is ancient history to you young guys. For us, it's like yesterday. What we're going to do is, the primary heading here is the early issues with the Oliver 1718 and 1955 tractors, closed center hydraulic system, which was new to that model at that time, in production starting in late '69. So you can see it's a pretty old story. We want to cover the reasons for and the advantages of closed center hydraulics on farm tractors. And then we're going to talk about who were the primary engineering personnel that worked on the development of the closed center system. And then we're going to discuss a little bit on the hydraulic component and circuit design. And we've got some hardware out here that you can look at afterwards or whenever. And then the basic premise of the talk is to discuss problems that occurred with the initiation of the closed center system on Oliver tractors and how we resolved them. And then we'll discuss lessons learned. What did we learn from that? Where did it go from that? If you open up your handout, on the second sheet, you have some diagrams. It's the one that looks like this. It shows a theoretical 3-position remote valve. On the left side, you have an open center one, and you'll see that the pump inlet is fed into the valve and passes directly out when it's in the neutral position. That's open center. The center of the valve is open to return. The closed center on the right side, you see the pump inlet is blocked off by the spool. When you move the spool left or right, it directs fluid to the respective work ports, which are usually called A and B ports. So what's the advantage of that system? On the next page of your handout, we've got a list of attributes for closed center and open center. Probably one of the biggest attributes of the closed center system is you have a variable displacement pump. And so when you back off on your RPM, the pump compensates for that and tries to deliver that, the maximum that it can actually at full stroke. You can read through those at your leisure. The next page on your handout is a list of the components that were changed to get the close center, and the characteristics. And I won't read through them, you can read through them on your own. Now, who generated this? This was generated by Ed Ketterling. This is actually his sheets that he used in 1969. You see the date on that, 4/1/69. And he used this to, to justify the work on the closed center system. We'll talk about Ed a little later here. Your handout also includes a early schematic. Looks like this. It's a pretty clean sheet of paper. And what that is it was generated on the 23rd of June, 1969. And why is that important? Well, that's important because it was just a few months before the 55 series even started. On the back of that sheet, you'll find another schematic, which is a real mess. It's not a very good print, okay? But I like it. Why do I like it? I like it because it's got detail, the detail of what's inside some of these components. So the point I'm going to make at this stage is that you see it's busier. And why is it busy? It's because we corrected all the problems that existed on that nice clean sheet of paper. Okay? We weren't short of problems. We had our hands full. So back to the system, the open center versus the closed center. Closed center is like your water system in your house. You go to the faucet, you open it, you got flow because you've got positive pressure on the other end. Open center is just the opposite of that. You have variable pressure. Constant flow. You have constant flow all the time, and you have to move the valve to get the variable pressure. So why did Oliver want closed center hydraulics? Closed center hydraulic systems were first applied to farm tractors in 1960 when Deere and Company introduced the system on their 3010 and 4010 tractors. In 1960, Ford introduced a closed center type, accumulator type system on the Ford 6000. In 1965, Massey Ferguson introduced their 1100 and 1130 series tractors with closed center hydraulics. Minneapolis Moline went to full production of G900 and G1000 tractors with closed center hydraulics in September of 1968. So you can about imagine how much pressure was being put on engineering, Oliver Engineering, to come up with a closed center system. They needed something to compete with the rest of the guys. I found an old Oliver Engineering schematic diagram of a proposed closed center hydraulic system dated the 24th of May, 1966. I've got it here. If anybody wants to look at it after the meeting, we'll open it up. It was designed by Oliver engineer Jerry Williamson, who had left the company by the time I had started, so I don't know the fellow, but obviously Oliver was looking at it in 1966. In fact, it had two different designs on one drawing. And like I said, Jerry Williamson left the company. And at some point, a fellow by the name of Ed Ketterling was put in charge of the hydraulic engineering group in Charles City. I've taken a look at the Williamson circuit, and I think that Ed and whoever was in charge at that time thought it was too expensive. It did have charging on it. And charging hydraulic system is you're providing a pressure flow to the inlet of the closed center pump. Closed center pumps are invariably piston pumps, variable piston pumps. So some of the limitations that Oliver had was that Deere manufactured their own closed center pump, along with all the valves. Steering valve, brake valve, PTO valve, differential lock, they made every piece, and they tooled every one. And Oliver just didn't have the resources to cover all that engineering and tooling investments in order to get, a complete system. One of the major advantages of the closed center was that it had good performance at low engine speed. You could throttle back the end of the row and still have quite a bit of hydraulic power available because the pump went into low gear and put out more flow. Okay, who worked on this design of the 55 series? Well, Ed Ketterling was a product engineer for the hydraulic group, lead engineer on the 55 series hydraulics. Ed was a UMD mechanical engineering grad from Streator, North Dakota. And he came to Oliver from Caterpillar. After leaving Oliver and Light Farm Equipment, well, that's probably wrong. Oliver left us. Anyway, Ed became chief engineer on the design and development of the new Case IH Magnum tractors. That's what he did after he left the company. Another fellow that we worked with was Bill Breezewitz, the senior designer. And so what's a senior designer? Senior designer is a very experienced draftsman. He isn't necessarily a graduate engineer, but we had a lot of those type of individuals at Oliver, and they were all very good people, very good. And they would do as much engineering as the engineers there. So, but Bill was from St. Ansgar, Iowa, which is down the road from Charles City, and very experienced designer, good detail man. After leaving Oliver and White Farm Equipment, he became a high-level parts manager for the Case IH parts system in Racine, Wisconsin. Now the next fellow, Jim Bassinthwaite. I'll turn the mic to Jim and we can explain what his responsibilities are.
Thanks. Thanks, Larry. Obviously, this presentation is mainly Larry's. I worked at Telec for a number of years, and I worked with Ed, Caroline, and I can remember Jerry Williamson. And I actually joined Oliver in December of 1967. So I was there, and then I guess it was the fall of 1970s when they moved us to Hopkins. So I was transferred to Hopkins. And my wife and I both came from small rural areas, and we didn't like the big city that well. So in May of 1971, then I moved back to Iowa to another manufacturer. I left Haugen. But I want to say that And actually, I was surprised when I saw John Culberson's name up on your slide. He was HR manager for Oliver at Charles City for many years. And in fact, in the spring of 1967, at a job fair at North Dakota State University, he came up there. And obviously several of us engineers were looking for jobs, talked to him. Well, then after he left or whatever, they called three people that had signed up at his desk and asked us to go down to Charles City for an interview. So that's what we did, and they offered all three of us jobs. I had to wait until the fall of 1967 because I had to go to another quarter school before I got all my credits and whatever. So I joined Oliver in December 11th, 1967. I just want to make one off comment too. My wife and I just got married in September, and my father-in-law, and I told her we're going to Iowa because I had a job there. My father-in-law said, "What do you want to go to Iowa for? They have tornadoes there." Well, I don't know if how many of you remember, in May of 1968, the tornado went through Charles City, wiped out the downtown, and like 13 people were killed. Of course, we were all right, and it really didn't affect the factory that much. That was interesting. But I really like Oliver. It was a good company, and it was a good start for me as a young engineer. We had a lot of good people, Ed Ketterly and other people, Larry. I don't want to say, I think this really helped you as a young guy and mentored you, and I learned an awful lot in those 3 years I was there that helped me throughout my whole career. And I want to make a couple comments about engineers. One thing that I'll say is one of the most important things I learned probably in my whole career. I think I've been with Oliver like 6 months, and they sent us out on a field trip. Me and I think 2 mechanics went to Wisconsin because of some of the problems they're having with some of the hydraulics. So we drove out there and we got to the dealership probably late afternoon. So we went to the dealership and he said, "There's no point in trying to do anything today. Why don't you go check in your hotel and come up to my house, we'll have a couple drinks and we'll go to work the next morning." So we went up to his house, it was very cordial, we had a couple drinks. So he said, "Okay, now what all you guys do?" And he asked the other 2 guys, and they both said they're mechanics. So he asked me, and I said, "Well, I'm an engineer." They said, "Hey, that's good, that's real good." So the next morning we showed up at the dealership, and he said, "I want to talk to you, Jim. You said you're an engineer." He said, "You guys screw everything up," and he just chewed me up and down. Made me feel about that high. But you know what? Every other time I went out, somebody asked me what I did, I said, "I'm from the factory." So I learned a lesson, so that was good. Just one more thing on engineers, and don't take offense. I don't know, we were 3-year engineers. Any other engineers in the crowd? Okay, well, hopefully I won't insult you. An engineer, especially when you come out of school, you have quite an ego. You think you're pretty good. But one thing we had when I worked in the R&D lab on some of the stuff, doing some testing or whatever, I realized in that one schematic, I don't know if it still shows it there or not, but there are 2 relief valves. And obviously in one system, you do not need 2 relief valves. And one engineer put them in one valve, and another engineer put them in another valve. So I went to both of them, I said, we don't need 2 of them. Why don't you take one out? And one said, "He's got to do it." The other guy said, "He's got to do it." So we never got it done. But Oliver had a program they called the PIP program, which is Product Improvement Performance or something like that. It was to reduce costs. And if you turned it in, a suggestion in, and it was put in place, you got a little reward. So I turned it in to reduce eliminate one of the relief valves. And I don't know who lost it, but I think, because I remember I got $70. And back in that time, $70 was a lot of money. And I don't know if those engineers ever talked to me again or not, or whatever. But we got the job done, I made a little money. But Oliver was very good. I really appreciate the time I had there.
Tell me where you're from.
I'm actually from Sarles, North Dakota. I grew up in a farm there. That's, some of you may know or may not know. It's like 60 miles straight north of Dove's Lake, right up on the Canadian border. It's one of those towns now. I think they have a bar left there, and that was all. But it's good up there. I always say I had 2 older brothers, and they both wanted to farm. And obviously my father couldn't divide up the farm with him. And both me and my father knew I wouldn't be a farmer. I just wasn't cut out, and I wanted to get into the big city. So it ended up, my one brother took over the farm, and I'm proud to say now, he's retired, his son's taken over the farm, and it's assured his son is very interested in farming. So the Bassinthwaite farm will be in at least 4 generations. So I think that's kind of neat. I'll get back to you.
Okay, well, I graduated from NDSU in 1966. Sorry. I graduated mechanical engineering from NDSU in 1966. And I started at Oliver in 1968. Actually, it was September of 1968, 3 months after the tornado roared through the town. And it was amazing that the town was in as good a shape it was after going through that tornado. It was really something. They had cleaned up really good. Anyway, later on I was transferred to the Hopkins, Minnesota White Farm Tractor Engineering Group. And in the fall of 1970 and January 1976, was transferred to Libertyville, Illinois. And in that transfer, they gave me a new title, Chief Engineer of New Tractors. I think they wanted me to stay. I didn't want to stay. After 8 years with Oliver and White Farm Equipment, I left the company in the fall of '76 and hired on as a systems engineer of hydraulics at Steiger Tractor in Fargo. With a progression of assignments, mostly in engineering management, I retired in the year 2000 as the chief engineer of current products. So what does that mean? I had 2 groups of engineers. I had a group that worked on nothing but 4-wheel drive problems, manufacturing problems, field problems, vendor problems, and I had another group that worked on the wheel loaders. And one of my responsibilities, which I don't talk about here in this, is that I had the responsibility for moving the wheel loader engineering and the test group and test apparatus from Wausau, Wisconsin to Fargo. Like I say, I retired in 2000, and then in 2008, I retired from farming, seeing it was so profitable. By the way, my farm is about 36 miles northeast of here. Going way back in time again now, we'll go to when I first started. I worked with Ed Gleason, the Charles City plant liaison engineer. And what he did was worked on manufacturing problems. If somebody had a problem on the line, then we got into fixing that. Very interesting job, and you got to see the whole plant. You got to meet all the people that became real important to you later on, because you had to pick their brain, because you're a wet behind the ears engineer. After 3 or 4 months of that, I was moved into Ed Ketterman's hydraulic design group. And the first job I had on the 55 was a 55 series job. And that was to design the new external 3-point hitch linkage that gets the draft signal into the hydraulic housing and through the servo valve. Further design work with Ed was focused on fixing manufacturing problems, addressing deviations. Deviations was something we would say, well, the junk man's come back again. And there'd be a guy from manufacturing that had a sheet of paper that was a deviation approval. So if a part was out of spec, we would review it to see if we could possibly use it the way it was, rather than throw it away. And surprisingly, some of the dimensions aren't really important on a drawing. May not be. Some are just terribly critical. So we had to be careful. Well, let's take a trip around the hydraulic circuit of the 55 series. The first item to think of is you gotta have fluid. So there's a type 55 hydraulic fluid. Now, how many people think that type 55 hydraulic fluid has a cause caused by the closed center system? The answer is no. That's kind of a shock. The 55 series tractors don't need 55 series oil. What did need it was the 50 series, where Saginaw changed to Vespel seals on their steering motor. And the Type 55 was really an oil that had been treated with crushed Teflon. And that would take a stick slip situation out of those steering valves to bind up a little bit. And that oil fixed that problem. So that may be a shock that 55 series oil isn't really needed on a 55 series tractor. But you know how marketing people are. They loved having 55 series oil to sell. And it continued on as being called out for use in the field. I don't even think factory fill was that. I think it was back to the old oil, which is basically a 10W motor oil. I think we were talking here at noon, some fellows, and the 55 series oil was also an ISO 32 oil. And what does that mean? Well, ISO 32 is basically 10 weight oil, 10 weight motor oil. Why should we be keen on using a 10 weight oil, such a light oil? Well, on the 55 series, you wanted to keep the inlet restriction to the pump as low as you could possibly keep it. And why is that important? Well, too much vacuum at the pump inlet can cause noise, cavitation, general wear on parts. So that's why you should use the thin oil on the 55 series system. We used a rather large Dreesen 10 micron cartridge type filter, again to protect the piston pump inlet, because piston pumps are delicate with contamination. That cartridge also had built into it a 5 psi bypass valve, which means in very cold conditions it would open and allow oil to get around the filter into the inlet. It seems contradictory, but you know, it's not perfect, but it did allow us to use that big filter and get oil to the pump. Now, Minneapolis Marine used an opposite approach on their 950 and 1050 series systems by trying to minimize the pump inlet restriction by removing their fine filtration on the return oils from the circuits, steering return oil to the reservoir. So which approach is better? And the answer is neither one's optimal. without charging. If you don't have charging, you're not going to have good inlet conditions. And we'll talk about that later. The main hydraulic pump is the PVD-15, right here on the table, made by Vickers. They made thousands and thousands of these pumps. Very close tolerance on the rotating group. This is a rotating group right here. And experienced company, basically a pretty good pump. It had its problems, not all were their problems, but generally pretty good. The pump is driven on the left side of the tractor with a bevel gear right angle drive designed by our ace gear designer, Vince Weber.
Yeah, he was not an engineer.
No, Vince Weber was a self-taught transmission gearing type engineer.
Probably as good as anybody in the country on gear design.
Very, very good guy. Lived to be 102, died, I think, about a year ago. A year or two. The pump's input shaft, I don't know if you can see it or not, it's a 13 tooth spline SAD type mount. 9 piston pump. 9 pistons are, on this pump, are important because it sets up a pump ripple that is very flat. And you don't want pressure jumping up and down, causing a lot of things to vibrate. So it's a 9 piston axial piston pump. And you know, rotary engines on airplanes, they're always odd numbered. And they're for the same reason. To smooth out the power pulses. I think I read someplace that there was 8 of these type piston pumps on a 747. 8 of them on there. Couldn't tell you the size or anything, but they were made by Vickers. Moving on to another component, different than the 50 series, but kind of related, was the control valve, or not control valve, the pressure control valve. And it had 3 valves in it, a 200 PSI pressure reducing valve section that provided power to the PTO and the hydraulic brakes. It had a backup system relief valve set at 2,500 PSI. So now we get to this situation of 2 relief valves. We've got the pump itself will cut back or maintain a certain pressure and not allow it to go higher, and it always tries to keep it up to the system pressure. But it still was an important thing to have, because you never know when one of these valves will get plugged up and cause an issue. So it was set at 2,500 PSI. Then there was a priority valve to give steering, PTO, and brakes priority. If you had some load that was taking a tremendous amount of flow, they would start to cut back on that flow in order to make sure that you had steering, you had PTO, you had brakes. This is no fun to lose steering or brakes. Jim, I'm going to have you comment on your work with getting some stability into that priority valve.
One problem we found when we were doing some initial testing was that priority valve didn't know which way to go and sit there and chatter back and forth. And I think at that time Jerry Williams was there. And I was working with him and Ed Ketterling, and I think Williamson came with that, he had to have little grooves on that priority valve to let it feather back and forth. But the challenge was what size of groove and how many grooves. And I don't know how many times we tried different, and it was just kind of a trial and error. We'd try a groove and see what it did. It wasn't quite deep enough, it wasn't quite long enough, so then we'd change it. I don't know how many we went through, we finally got it where it was pretty good, and we kind of solved that problem of it shattering. So, I think at that time, we're almost into production. I don't know, you made a comment to me that me and Ed Ketterly were running around trying to figure out what to do. We got it solved anyway.
I think that occurred probably a week before production. And we had a good centerless grind vendor that would make the spools for our valves. And they could respond like overnight. So a week doesn't sound like much, and it wasn't. But we got by pretty lucky on that. But it was down to the wire. Okay, I'm going to talk a little bit about an unloading valve. This guy right here. And it solved the problem, and we're going to discuss that problem in more detail as we get further down the line here. But that was keyed into the outlet of the hydraulic pump. And what it is a snap closed valve. When 3.4 gallons of oil goes through it, it decides to move the poppet and seat it and shuts that flow off. Well, why would you want to do that? Well, it creates a starter load. This guy here, if he's turning, he's wanting to pump. He wants to generate that pressure. And what does that do while you're cranking? It puts a bigger load on your cranking motor on your engine. So the unloading valve really solved the problem of getting tractors started. 1950 was an especially bad one that way. So, but it got put on all the flow center tractors. PTO valve, I've got a sample here, and we'll talk about that later. But that operates the PTO clutch and the PTO brake. Turns them on, basically. Brake valve. We would buy Cessna brake valves. We weren't the only ones that were using that brake valve. I know that IH used them in the mid-70s, still on their 66 series tractors. So it is probably a pretty widely used valve. And that operates on the low pressure circuit again, the 200 PSI circuit. Added later on was a cooler pump. This guy here. This is a Cessna pump. It was used in the past on earlier Oliver tractors for, I think, power steering, before my time anyway. And it was added to the tractor very last minute to provide cooling flow for the hydraulic system. It's a 5.5 gallon pump, by the way. And it's got a 100 PSI bypass valve built into it. And that thing should live forever. I'll tell you a story about it though. These showed up in the warranty. In fact, this came from Oliver warranty. And it snapped the shafts off. And I don't know if we ever came up with a reason for that. There wasn't very many of them that came back. Maybe we saw 8 or so of them back in warranty. And I don't think anything was done about it. It most likely snapped off because of belt load or somebody dropped it on the floor. It does have a stress riser on the shaft, so it's a possibility that they cleaned up the design. I just don't know on this one. Okay, well, now we get to the fun part. So production has started, and now the problems start up. So one of the first problems we heard of was guy was out plowing, moldboard plowing, and he lost steering. Well, we scratched our heads for a while on that one, and then the test department came to the rescue, and they put plastic tubing on the inlet to the main pump. They had a hose on here, it was clear plastic, and they had a hose on the outlet. And while that test tractor ran, just standing there, air would settle out in the top of the filter head, because the filter head feeds this pump. And then when the control was operated to turn flow on to a function, it would sit and cavitate. It would spin in that air bubble that gathered in the inlet to the pump. So how are we going to solve that? Well, luckily enough, right before production, it was determined that the tractor needed cooling. So this guy was added right at the last minute. Two versions of these, I believe. There's a high mount and a low mount. And it's a small pump. Like I said, it should run forever and ever. And the filter head had at least 2 tap ports in the head, an aluminum head. And they're just the right size. So we ran a 1/4-inch line from the pump inlet to the top of the filter, and it sucked the air out of the filter. Solved that problem, and they were on all the rest of the production. I think most everything got changed to add that little 1/4-inch line, and it drew the air out handily. We didn't need, it doesn't take much to suck the air out. But the big problem on the 55s was the Synflex hose fiasco. Synflex hose was a thermoplastic hose. It had a thermoplastic liner. And you really couldn't tell it much different than any other hose. But the tractor has a fair amount of hoses on it. And the tractors had just gotten out to the field in customers' hands, and they were popping these hoses right out of the sway shafts. The reason? The thermoplastic couldn't stand up to the heat. It was plain and simple, it couldn't stand up to the heat. So somebody had sold, somebody in the hydraulic group, and I won't say, but well, I'll say Ed, got snookered on that one. And we switched to good quality Gates production hose, 100 R2s, 100 R1s, and never looked back at that problem. But it was kind of a real issue for a while. Because it didn't take anything for the system to get hot, and they'd start popping. So I believe everything was changed out in the field. There shouldn't be any tractors out there with Synflex hose anymore. That was my bucket truck that was got full of Synflex hose on
Yeah,
you mentioned the bucket truck, obviously in an aerial device or on digger derricks too, you have an insulated boom for part of the way. Well, obviously in an insulated boom, you can't have a wired hose going through it. So that's why they use Synflex, because there's no wire in it. So you don't have any way to, conduct electricity. And that has to be inside or be part of those insulated booms. So Telec, I went to Telec after I went there in 1981 in Watertown, so lived in Watertown ever since. But Telec built a lot of digger derricks and aerial devices using that Synflex hose.
This is a kind of a test sample of the flange that goes on top of the steering unit. And in the closed-center systems, we used a Charlin steering control valve. And the column we also bought from Charlin. And that was only some of the few advantages being in Minneapolis is you could just drive down the road and you'd be at Charlin. Or you drive down the road and you go to Pioneer Couplers. So we had a few advantages being in Hopkins. Anyway, these are breaking off in customers' hands. And so Charlin had to whoop up their welding process on it. This is a coupon, I guess they call it a coupon, to check the weld quality. And they corrected their weld quality quick. And then somebody came up with a plan on how to test that out in the field, and that was to put a 125-pound side load on the steering wheel. And if it passed that, it was good. I don't know if any of those broke. We never heard a problem after they whooped up their weld process. So that was a clear vendor problem. Like I said, the engine hard starting on cranking, occurred. Boy, it must have been really close to the start of production. Because the date on the prints here is November 19th, 69. And, that's about the time production started. So it was a last minute inclusion on the tractors. So I think all tractors got changed that they had already been changed. So we were up in Hopkins at that time and got a call from the service department that a customer had a 1955 tractor that he used year-round in a feedlot, and he had no brakes. Well, this was in January. So we had some suspicions already of what was causing this. So I set up a tractor, production 55 series tractor that we had in engineering in Hopkins, set it outside overnight with the block heater plugged in. So it got down to 10 degrees below that night. And I got the tractor running because it was heated, and took it out in the parking lot. I stepped on the brakes and I waited, and I waited, and I waited. I waited 21 seconds and the brakes finally came on. So that was enough of a test right there to convince us that we had to either reduce the pressure or the flow. I'm saying it all wrong. We had to reduce the restriction to flow or increase the flow somehow to the brakes. And so we upsized the brake tubing that goes from this valve down to the brake housings on the left and right side of the tractor. And I did that after I did the calculations. The calculations told me that to get a half-second brake delay, which is I pull that out of the air, I'd have to have 2,000 PSI to get that brake to come on. So you see we had a ways to go there. This would come to bite us again, this low pressure, 200 PSI, low pressure circuit, because it's real sensitive to any cold weather conditions. But we replaced the small brake lines with larger tubing, and never heard of a problem again on that. I think probably everybody here has thrown on the PTO lever, and then bang, everything's shaking in the back. You know, got a real quick acceleration of the PTO shaft. Well, it was mounting complaints along those lines, and so I was given kind of carte blanche on what to do about it. So what I did is I came up with a means of determining when you would reach a point on moving your lever where you would actually pick up the load. And I did it kind of in an unconventional way. We have a detent ball in that that's hydraulically actuated and applied. And I added a mechanism in the bottom of the valve so that as you move the lever, you guys can come up here and try it later on. You reach that point right there where the load would actually pick up on the PTO. So the tolerances are hard to control. You really don't know where that point might be because various surfaces on the spool itself can vary and all that. But they ran all of these over a test stand in the plant anyway. So we came up with a solution to know where it was. They'd actually mount this to the test stand and they'd adjust the spool to where they got an X amount of flow to the PTO clutch. And that you knew that if it got that, it would engage the PTO. So there's a point in here, I kind of call it faint feel. You move the lever that far and you can feel it's picking up the springs down in this end of the valve. And released it, never heard a thing back on it. By the way, this is the 50 series valve, and it's modified. We added very little material, and I think my garage is over there, you can see it. And the thing is completely interchangeable with the old one. The mounting holes are the same, the ports are the same, everything's the same. So it's kind of a win-win deal. And the hydraulic detent provided a safety feature. You shut the tractor off, the valve returns to neutral because all the detent load is gone. We've already talked about the unloading valve. Let's see, what else do we have here? Well, I guess we'll get into the big guy. I'll call this the big guy, the Vickers piston pump. Lucky me, I was assigned the job of participating in the inspection of warranty returned closed center pumps. So you'd think that might be a big job. Well, no, I had to just walk across the street because the return goods for Oliver and Minneapolis were in the basement of the main office of Moline headquarters, and it was right across the street from our Hopkins engineering office. Just one comment on the Hopkins engineering office. The third floor was vacant, occupied by the pigeons, I think. Remember that? And the stairway up to the third floor was so thin you could see air through the steps. But anyway, the third floor was used to oil bearings for threshing machines. That gives you an idea how old that building was. We never had good engineering facilities, did we? It's always kind of dumpy. Something made us strong, right?
Which you can't deliver it if you like it to get there.
Well, that was pretty fancy, yeah. Well, anyway, these return parts came to that location, and every once in a while, probably once every 2 or 3 months, they'd call a meeting in there, and we'd have a warranty person, a service department rep, and if possible, and most of the time it was, we'd get the rep from the vendor. And so what was really important to us was the pump problems that we got back. So we'd take each pump apart and assess what went wrong as best we could. And we'd have the warranty claim, we'd have anything that the dealer put on, a tag, you name it. We'd weigh it as to who should get it. And so we determine if it's a Vickers problem, we'd want it to go back to the Vickers, and the guy was there to accept it. So they got shipped back to Vickers. If it was our problem, it would be, I can't name what it would be, but we'd get that, we'd keep that one. Sometimes the safety wire seal on the compensator here, at the end here, was cut. So you know somebody had been in there and adjusted the compensator setting, which controlled the pressure. I can assure you that there was no warranty claims that were ever denied because that wire was cut. There wasn't anything that was, nobody got shorted on that. But all of them had the wire in there. And I guess you could make some assumptions. You could make some assumptions that from the factory, maybe Vickers didn't set the pressure right. Or if the wire was gone, somebody could have been playing around. And why is that important to know? Well, you can set that one higher than the safety relief valve in the high pressure block, or the pressure control valve on the left side of the valve. So you could get that interaction. You could get one opening up when it shouldn't. So anyway, but taking them apart was very interesting and learned a lot. And I'd say 30% of the pumps that we got back had absolutely nothing wrong with them. Now that's for the first year or year and a half, but by and large, I'd say that 30% didn't have any problems. So I'm standing there and I'm saying to the Oliver guy, the service rep, the vendor, I said, well, you don't want it back, and what are you gonna do with it? Well, we can't put it in parts. So used part. So I'd say, can I have it? And they'd say, yeah, you can have it. So that's how I got this pump. I believe this one came out of 1755 with 89 hours on it. So I got some pretty good parts. Let's see here. But that was a good experience, to learn what was going on. Well, we found some Vickers problems. There's a lot of powder metal parts. You say, oh, powder metal, we don't like powder metal. Well, the spherical washer here, that's powdered metal. The cage on these pistons, that's powdered metal. There's a swash blade inside that this drives against. So sometimes we'd find those cracked. Could be a metallurgy problem or not. And those definitely went back to Vickers. One of the things that we saw happening on the pumps, and it's really hard to do that, explain it to you without pulling it apart. And what I'm going to do, if anybody's interested after the meeting here, we'll strip this thing down. It'll take maybe 5 minutes, and you'll see what I'm getting at. But there is metering grooves in the end plate, in this cast iron plate, that ease the fluid either going into the pistons or coming out of them. And sometimes you'd see erosion happening. It would actually pock metal the end plates. And what causes that? Well, it's the same way with cylinder liner cavitation on your engines, where the ringing in the cylinder causes the cylinder liner to move, and it collapses air bubbles. And that collapsing air bubble takes a little bit of metal with it as it goes back into the oil. So we'd see that. And that would be all the more reason for trying to keep the inlet conditions low, is that it would tend to create more of those problems of erosion of the end plate. The other problem we saw related to the same thing is those are called shoes, piston shoes, and they would actually cock, not stay flat against the swash plate, and it would cause something called shoe roll. And we were very interested to control that with good inlet conditions again. The lower the inlet, the better off you are. Let's see here. So what did Vickers do to improve the situation? Well, they would adjust their powdered metal specs on those parts we had talked about. They also put an internal check valve so that the case drain, or the case area, which is submerged in oil, this thing is full of oil. If a pressure spike happened in there, it would go right to the inlet where basically harmless. So that helped our inlet conditions quite a bit. I looked up the price of replacement pumps at a dealership, and they want $2,900 for one of these things. And I don't know where it comes from. But I do know this, that Chinese parts are available for these pumps. About every piece. And I'll bet you dollars to donuts that if you find a rebuilt pump online, they might say it's got new parts. It's got those Chinese parts in it. So unfortunately, it's kind of an expensive item to replace on your tractor. So why did we have these problems? Some of them seem kind of simple, but here's the deal. The 55 series program had only 200 hours of field test on production quality parts. There's no secret why we had these problems. That was it. I can't put the blame on any individual or a department or what. It just happened to be that way. I suppose design got most of the jobs for that. But anyway, yeah, 200 hours. And I happened to be in the room with Bob Prunty. And who's Bob Prunty? Bob Prunty was one of the lead engineers. He was the chief engineer of Oliver Tractor. And really a good guy. But he went on the record, he said, we would never have another tractor program that has only 200 hours of field test on it to pass it. So I remember that for many, many years. You wouldn't have that low of test hours. And in fact, I was involved with the 2 on 35 and the 2 on 55 hydraulic programs, and we had a hell of a lot more than 200 hours of test on these tractors. Okay. Cause and effect. Finally, the distractions. Moving to Hopkins, away from Charles City, which I went through. And we moved in the early production days of Oliver's 55 series. That wasn't helpful in fixing problems because we were worried about where we were going to live. And another fact is that I had 8 years at Oliver, and in 7 years of working there, there was rumors that we were going to move, and not only that, but we moved twice. Charles City to Hopkins and Hopkins to Libertyville. So that's not conducive to staying and fixing and moving on with life. So after that many years, 8 years, I actually got to a point where I said, you move my desk and then I'll think about moving. I'm not going to go out there and buy a house like some people did. And it actually made the move to Libertyville would not have happened. 5 people have gone out and bought a house. I found that out years ago. Now, each one of these moves, you lose people. And I'll just use this one example. We had over 100 people in engineering in Charles City. When we moved to Hopkins, 27 of us moved. We lost 2/3.
They move on or take other positions in the company.
Moved on.
Yeah.
They were gone. They didn't get invited to the party. And there was only 27. Back on this moving stuff, Ed Caroline, Griswitz, and I, we moved before anybody moved. We moved to the Hopkins before any one of the rest of the design group. We were at least 6 months before they did. And I can only think of one reason they did that is the Minneapolis Marine's hydraulic guys were all gone. They didn't have anybody. So, actually, we were the guinea pigs anyway. So let's talk about what was learned here. After the experience we gained from the 55 series tractors, the hydraulic design group was convinced that charging the hydraulic pump, priming the pump, putting flow right to the inlet of the pump was a necessary method to be used on any subsequent new tractors. And I got involved with the white 4180, 2135, 2155 closed center hydraulic systems that we designed, and each one of them had charging. Now, preparing for this and the other meeting that we had a few months ago, I found on the internet, on the Ag Talk forum, a report by Price Farms. I'm sorry, I don't know just where the Price Farm is located, but they had a 2135, and they reported they had owned that tractor since new, and they had its motor and power shift transmission overhauled at 10,000 and 12,000 hours, respectively, and that they had recently replaced the hydraulic pump on that tractor for the very first time with 17,000 hours on the clock. Mark that as success. That was overwhelming evidence that charging was the way to go. And finally, I used what we had learned at Oliver and all closed center hydraulic systems ever built on Steiger, Case IH, four-wheel drive, not Case IH, but on the Steiger Fargo built tractors. They all utilized charging of the hydraulic system, the closed center hydraulic system. And I'm about topped out. Any questions?
So 55 series never did get a charge.
No, they never had charging. There weren't as much threats on our life.
Mary, how do
Just
you
talk about
take 55 series? Can it be a good hydraulic system, or is it always going to be kind of vulnerable and short life? In your opinion? Because it doesn't have charging.
Well, if you take good care of it, change oil, change filters often, keep the inlet restrictions down, it'll go quite a while. Not as long as charge systems. They'll run, 17,000 hours. My God, can't expect much more than that. So, say your question again. What
Well,
is
I'm
that
just wondering, is it
state of the
Is it
art?
always kind of a vulnerable, short life system, or can it be kind
Well,
of reasonable?
that's the service guys. You know, I've been away from the Oliver since 1976. It's a long time. I've forgotten an awful lot. And I don't have the contacts. Well, I'm sure.
Because of the cavitation that hammers on those pumps, because of no charge. Cavitation. I worked for John Deere, we had the same problem. We had the charge pumps. And the pump would go because it was cavitated.
Yeah, it'll heat up. It'll heat up enough that the performance starts to go down. And then the performance goes down, the heat builds up. It's just kind of a vicious thing. can't hear
How
you.
did they put charge pressure in the white system?
The weight system? Well, we had a gear rotor pump inboard in the main pump.
Okay.
And we designed that pump. Gear rotors,
Sure.
good pumps, last a long time. There's no pressure requirement. You only want to charge to, well, 10, 15 PSI. You're not asking for it to put out a lot of pressure. And then the opportunities opened up to us to use some of that flow to go through the cooler. We used it. So, yeah, we got rid of this guy and 235.
Lane 55 service, they don't even pay that, so that tractor's already got a G rotor?
No, I don't think so.
I've got one, it doesn't have that pump on it, never did.
Oh, it never did. Yours got skipped. It got missed. It must be an early one.
No, it's a late one.
Oh, late one.
74.
Was it a 2105? No, it was a 55. Beats me.
I've seen cars like that too.
Come up to me afterwards because I can't hear you.
All right, anything else?
No, just, you're welcome to look at all this stuff and see what the hardware looks like.
Let's give a round of applause.